This video lecture focuses on the functions of lipids in food, including both baked and non-baked food products. We will begin with a quick review of the different types of lipids. There are two main classifications or types of lipids. The liquid oils, such as vegetable oil, corn oil, and canola oil, are those that are liquid at room temperature. They have a greater tenderizing ability in baked goods and are used for frying foods, such as deep fat fried anything. The solid or plastic fats are those that are solid at room temperature. Plastic fats are those that are moldable or take the shape of the container in which they are in. Solid fats, such as shortening, butter, and lard, provide for greater flakiness in pastry and biscuits and have a greater creaming ability. Oil is 100% fat, whereas shortenings, margarine, and butter are about 80% fat due to the inclusion of air and additives in the shortening and the milk solids in the margarine and butter. This makes more of a difference in the functionality of lipids in baked goods. When we look at the composition of stick versus soft or spreadable margarine, the main difference here is that the stick margarine has less water. The softer spreadable margarine, such as I can't believe it's not butter, or what we sometimes call the tub butters, they have more water added. The softer the margarine, the more water that is in that margarine. This is another tactic that food manufacturers use to lower the number of calories in margarine. They just add more water. They whip in air and water into the margarine. Shortening, remember, is about 80% fat, but some of those shortenings can also have emulsifiers added to them. If you look at the label on the bottom of your slide, look there in the ingredients and see the mono and disaccharides listed. Those are the emulsifiers. The added emulsifiers are great if you are making cookies and cakes, but not so great if you're making pie crusts. So really, who knew all of these differences between the different kinds of lipids? With this brief background in mind, let's shift our attention to the functions of lipids in food. Lipids have a variety of functions in the foods that we eat. There are 6 different functions listed here, and we're going to talk about each of these in more detail in the upcoming slides. So first, we have the oils and their role in emulsions. If you will remember, an emulsion is a dispersion of liquid within another liquid in which it is not soluble. Okay, so it's 2 immiscible liquids that we are trying to get together. So we have 2 different types of emulsion, the temporary emulsion and the permanent emulsion. So the temporary emulsion is an unstable mixture of 2 immiscible ingredients. So immiscible are those that do not mix. A temporary emulsion forms when the 2 ingredients are shaken together and temporarily combined. Then, if you let them sit, the 2 will separate out again. So an example of this would be the vinaigrettes that you have located there on the bottom of the slide. When you shake them together, all those ingredients mix, but then as you let the vinaigrette sit on the table for a while, those ingredients will separate out. The second type of emulsion are the permanent emulsions. And permanent emulsions are a stable mixture of 2 ingredients that normally do not mix. They do not separate out when left standing. Okay, many times a permanent emulsion has an emulsifying agent added. Examples of permanent emulsions, we've got the hollandaise sauce, which is the picture there on the left, and mayonnaise. Fats and oils also act as tenderizing agents in baked products by tenderizing the gluten. Remember, the gluten are that protein complex that provides for the rigidity and the structure of the baked good. Fats and oils will interfere with the development of the gluten, and they will shorten the gluten strand by physically coating the gluten and softening the gluten molecules. So which one do you think would be a better tenderizing agent in baked goods? An oil, a liquid oil, or a plastic fat? Fats can also provide flavoring to a product, but they can also enhance the flavors that are already present in that product. For example, you might add fats for seasoning or into salad dressings to bring the flavor to the food that you are eating. Also, fats can take up or dissolve certain aromatic flavor substances. This is one reason why onions and peppers and other foods are sauteed in the fat to produce that savory fat flavor in those vegetables. The color will vary by the type of fat or oil used. So if you think of the yellowish color of butter versus the whiteness of shortening, those color differences will make a difference in the final baked product. In terms of texture, this again will vary depending on the type of fat or oil used. Remember that a plastic fat, such as shortening or lard, is very good to make a flaky pie crust or a biscuit. Creamed shortening will add a sense of moisture into a cake. Fried foods, it's that the fat will be responsible for that crispy coating. And then if you think of dairy products, the fuller fat dairy products such as the cream or the half and half, the thickness, the viscosity, and the creaminess of those higher fat dairy products is due to the fat that's in the product. Let's take a moment here to apply what we've learned when looking at pie pastry. So the type of fat used when making pie crust will yield different characteristics in terms of the color, the flavor, the volume, and the mouthfeel. You want to use a solid plastic fat like shortening or lard in order to be able to cut that fat into the flour that will ultimately yield to this flaky texture. With oil, you will not be able to get the same texture because of the fluidness of the oil. The oil will ultimately coat the flour, leading to a more tender pie crust, but we won't be able to cut that oil into the flour to make those fat balls that ultimately flatten when we roll out the dough. Generally speaking, a plastic or moldable fat will yield the flaky pie crust, and the liquid oil will yield a tender pie crust, but not so much a flaky one. Butter will yield a very flavorful pie crust, but butter is too hard. It's too hard to cut into that flour, so butter is not one of those plastic fats. Another application here would be when we look at lipids and the role that they play in chocolate chip cookies. I am always on the hunt for the best chocolate chip cookie recipe. As you can see in this visual, the type of fat really does make a difference in the appearance as well as the flavor of chocolate chip cookies. The margarine, remember, has a higher percentage of water, so it's going to have a greater cookie spread. The butter will give a great flavor, while the shortening gives the cookie that real perfect look. Are you a lover of ice cream? Boy, I am. The smoother and the richer the ice cream, the better. But when the ice cream has those solid sugar crystals in it, I'm really disappointed. The fourth function of fat is its ability to control the size and rate of crystallization in candies, icings, and ice creams. Crystallization is the process by which sugar crystals form and how they come together in aggregates. The fat helps to control the number, the size, and the distribution of the sugar crystals in a pleasing form. This is important because the crystalline formation will affect the texture, the flavor, the appearance, and also the spreadability of this sugar-sweetened substance. When we look at lipids in meat, we think of this perception of moistness or juiciness. If you remember there, looking there on your left, we've got the different types of fat. We've got the fat that surrounds the outer cut of the meat, the intermuscular fat, and then we've got the intramuscular fat or the marbling. If you remember, the tender cuts of meat have more marbling, so that is going to be more fat that melts, that gives that perception of juiciness and moistness. The leaner cuts of meat have less marbling, so with that they're going to have a lesser sense of juiciness or perception of juiciness or moistness. The last function that we're going to chat about is using lipids as a cooking medium. Examples of this would be pan frying, or deep fat frying where the whole food product is totally submerged in the oil, stir frying, and sauteing. When we think about using oil as a cooking medium, we really need to consider the smoke point. And the smoke point is the temperature at which the fat begins to smoke, indicating that its chemical structure is beginning to break down. With continued heat, the oil could actually burst into flames. So I don't know how well you can see it here in the picture on the slide, but you can see all that steam raising up off of that oil. In time, that steam will turn bluish. It will become more smoky, and with continued heat, truly, it could burst into flames. So as we think about smoke points, I want you to realize that various fats have different smoke points. So take a moment here to review the various smoke points of lipids. On the graphic, we've got the temperatures are mixed up. So the middle column there are the degrees Fahrenheit, and the final column are degrees Celsius. So as a point of reference, remember that boiling water is 212 degrees Fahrenheit or 100 degrees Celsius. As you can see, the smoke point of lipids is significantly higher than the boiling point of water. This is what makes fats an excellent cooking medium, because they can cook the foods to a much higher temperature than what water can. These higher temperatures lead to the crispy French fry or chicken nugget rather than a soggy one. When deciding which lipid to use, we need to think about 4 different factors here. First of all, what is the purpose of the lipid in the recipe? If you are making a pie crust or a biscuit, then a plastic fat, such as shortening, is the way to go. If you're looking to make muffins, then you're going to want to use oil due to its tenderizing capability. Remember, in muffins, we don't want to overdevelop the gluten, so if we have a liquid oil, that's going to spread out over that flour and help to tenderize the muffin. Second thing to consider is that different lipids have different flavors. So think about the flavor of olive oil versus the flavor of butter versus the flavor of shortening. Do you want a neutral flavor? If so, then you might consider canola oil or vegetable oil. Or do you want the flavor of the dish to be enhanced with a stronger flavored oil? So maybe perhaps olive oil or peanut oil for an Asian stir fry. Third consideration is the cost. Cost is a factor in many things in life, including the lipids that we purchase. Extra virgin olive oil and rapeseed oil can be very pricey. So you need to weigh the cost against the reasons why you would like to use that oil. I have found that canola oil can be a very nice compromise as it has some of those heart-healthy features of olive oil, but not the cost. Neutral flavored oils and shortenings are more versatile than the stronger flavored ones. I like to bake using unsalted butter so that I can adjust the amount of salt in the baked product. Thank you for listening. I hope you learned a thing or two.